Hi, my name is Steve. I'm your teacher buddy. Welcome to my channel. Okay, let's talk about integers. And of course, this is everyone's favorite topic. In this video, I will show to you how to add integers. In adding integers with the same sign, just add the numbers and copy the common sign to the sum. Okay, first example. Positive 10 plus positive 5. Here, they are both plus sign. With that, we only need to copy the common sign to the sum. That is, plus. Positive 10 plus positive 5 equals 15. That's your answer. That was so easy, right? Okay. Next example. Negative 6 plus negative 4. They are both negative. Again, copy the common sign to the sum. And add. 6 plus 4 equals 10. And that's your answer. Negative 10. Okay. Next problem. Negative 18 plus positive 4. This time, we have different sign. In adding integers with different sign, disregard the sign first, then subtract the smaller number from the bigger number, and copy the sign of the bigger number to the answer. Disregard also the signs in identifying the bigger number. So, negative 18 plus positive 4. Because this is different sign, we need to subtract first the smaller number from the bigger number. 18 is the bigger number, so 18 minus 4 equals 14. Then, we need to copy the sign of the bigger number, which is negative. Negative 14 is the answer. Alright. Let me give you another sample. Positive 4 plus negative 3. The biggest number is 4. So, 4 minus 3 equals 1. Then, copy the sign from the biggest number, which is positive. Positive 1 is the answer. Good job. Now you know how to add integers. Wish you all the best in your mathematics adventures. Thank you for your time and have a great day. Hi, my name is Steve. I'm your teacher buddy. Welcome to my channel. In this video, you will learn how to change decimals and mixed decimals into fractions in easy way. Let's answer this problem as an example. Change 0.25 to fraction in lowest term. The fastest way to write decimals as fractions is to write the number after the decimal point as a numerator and then use the power of 10 as a denominator. The number of digits after the decimal point will tell you how many zeros the denominator must have. When we say power of 10, it's 10, 100, 1000, 10,000, and so on. Okay, let's answer. Let's write 25 as a numerator. And then the denominator that we are going to use is 100. Because there are 2 digits after the decimal point. Let's count 1, 2. So that means we need to use a power of 10 with 2 zeros, and that is 100. Next step is to reduce the fraction to lowest term. We need to divide the numerator and the denominator by finding the GCF. So, if we are going to get their GCF of 25 and 100, the GCF will be 25. Then divide 25 divided by 25 equals 1. 100 divided by 25 equals 4. So, 0.25 is 1/4 in fraction. Very easy, right? Let's have another problem. Convert 0.025 into fraction. We will write 25 as a numerator, because that is the whole number after the decimal point. Although, there are 3 digits after the decimal point. But, we will write the number as a whole number, since there are 3 digits after the decimal point. So, we will use 1000 as a denominator, because the number of digits after the decimal point must be equal to the number of zeros in the denominator. Next step. Reduce the fraction to lowest term. Divide the numerator and the denominator by their GCF. The GCF of 25 and 1000 is 25. Okay, let's divide. 25 divided by 25 equals 1. And 1000 divided by 25 equals 40. So, the answer is 1 over 40. Next. How to write 5.9 in fraction. This time we will convert mixed decimal into fraction. In this number, 5 is the whole number and 9 is the decimal number. To change this into mixed fraction, we will just write 5 as a whole number, and then 9 as a numerator. And we will use 10 as a denominator, because there is only one digit after the decimal point. As I've said, the number of digit after the decimal point must be equal to the number of 0 in the denominator. The next step is to reduce the fraction to lowest term. But in this case, it is already in lowest term, because the numerator 9 and the denominator 10 do not have other common factors aside from 1. So, our answer will be 5 and 9 over 10. Good job! Now you know how to convert decimals and mixed decimals into fractions. Wish you all the best in your mathematics adventures. Thank you for your time and have a great day. Hi, my name is Steve. I'm your teacher buddy. Welcome to my channel. Okay, let's talk about integers. In this video, you will learn how to divide integers. Let's divide first the integers with the same signs. In dividing integers with the same signs, the quotient is always positive. Okay. First example. -10 divided by -2. 10 divided by 2, our quotient is 5. Here we have same signs. So, the answer is positive 5. Next example. +6 divided by +3. 6 divided by 3 is 2. The signs are the same, so our answer is +2. Now, let's divide integers with different signs. Okay. In dividing integers with different signs, the quotient is always negative. Here our example. -30 divided by +10. 30 divided by 10 is equals to 3. The signs is different. So, our answer is -3. Last example. +30 divided by -2. Our quotient here is 15. Again, we have here a different signs. So, our answer will be -15. Good job! This is how to divide integers with different signs. The quotient is always negative. Now you know how to divide integers. Wish you all the best in your mathematics adventures. Thank you for your time and have a great day. Hi, my name is Steve. I'm your teacher buddy. Welcome to my channel. Today, what we're going to be having a look is a way of really rapidly working at percentages of a number. And this is something you can easily do in your head, without having to pull out a phone or anything like that to work it out as calculator. Give you an example of this. What is the 30% of 40? Now look, I can answer this straight away as 12. Now, I tell you how I did this. And this is literally how quick you can do also. Okay, so if you had something like 20% of 180. I'll show you how you do all these other ones in a second. So, 20% of 180. The way that you go about doing this, you can cancel out your zeros. So, 2 times 18, you will get the answer of 36. Alright. What about 50% of 40? So hopefully, what you're doing is you've cancelled out those two zeros and you've got 5 times 4. The answer is 20. That's really easy, right? If you haven't been doing that method already, you probably feel like you've been a little bit rubbed. I'll show you what you do once they start to get a little bit harder. Look, even we say something like 20% of 18. So, we're dividing by 10. Here, we're getting 1.8. You're going to see this each time we're cancelling out those zeros we're dividing by 10. So, we're ending up with 2 times 1.8 is going to be 3.6. And that's the answer. Do you get that? I'll give you another example. You might feel confident enough to do this yourself. 30% of 12. So, we get rid of that 0. We jump the decimal place here, so 3 times 1.2. We're going to get the answer of 3.6. Alright. What is the 40% of 15? Hopefully, you know the answer to this already. Right? Get rid of that 0, then jump that 1. 4 times 1.5. And we get the answer of 6. And that's the correct answer. That's really easy. Hopefully that was some help to you. Hope you enjoyed the video. Bye, see you next time. Hi, my name is Steve. I'm your teacher buddy. Welcome to my channel. For today's video, we will discuss the introduction to sets. So, what is sets? A set is a collection of well-defined and distinct objects. These objects are called elements of a set. We have here two words, collection of well-defined and distinct objects. This is the two characteristics that for us to say that those things are examples of a set. So, for you to have a deeper understanding about sets, let's start with the example number 1. Set of colors in the rainbow. We have the red, orange, yellow, green, blue, indigo, and violet. Why this example is a set? Because this is a well-defined type of a set. Because the rainbow has no other colors. We can easily say or identify, illustrate, and enumerate the different colors in a rainbow. Because this is already established. These colors are called the elements. Okay, so let's move on to another example. Set of even numbers from 2 to 20. Do you think this example is a set? Yes. Because this is well-defined and distinct objects. But what are the elements? The elements of this set are 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. They are even numbers. These are the elements of the set of even numbers, from 2 to 20. Example number 3. Set of the months in a year. What are the elements? January, February, March, April, May, June, July, August, September, October, November, and lastly, December. Here, we have 12 elements. We all know that in 1 year, we only have 12 months. Therefore, distinct and well-defined, our example number 3. Now, I will show you a non-examples of a sets. In order for us to deeply understand the concept of a sets. Example number 1. Set of senators. Why this example is not defined and distinct? Because there are different sets of senators. It depends on the country. Every country has a different senator. So that, we will have a different answer for this example. Let's go with number 2 example. Set of beautiful artists. This one is also included in the non-examples of a sets. Why? If I'm going to write a set of my beautiful artists, maybe in your perspective, the set of beautiful artists for you are different from mine. Right? Therefore, example number 2 is not an example of sets. Again, these two examples are non-examples of a sets. Now you know how to identify whether the given statement or the given group is an example of set, and also the elements of a set. Wish you all the best in your mathematics adventures. Thank you for your time and have a great day. Hi, my name is Steve. I'm your teacher buddy. Welcome to my channel. How can we solve problem like this? 10 minus 5 plus 6 times 3 equals. In this video, I'm going to teach you how to solve this problem. In solving problems involving two or more operations, we follow the MDAS rule. What is MDAS rule? MDAS rule is the correct sequence of operations that we need to perform in a problem to get the answer. M stands for multiplication. D stands for division. A stands for addition. And S stands for subtraction. In MDAS rule, we need to solve first the multiplication and division. We solve it left to right. That means, perform whichever operation comes first. Next, the addition and subtraction. Perform whichever operation comes first. Okay. Let's solve this problem. 10 minus 5 plus 6 times 3 equals. Here, we have three operations: subtraction, addition, and multiplication. We need to solve first the multiplication. Equals, let's copy 10 minus 5 plus, and the answer for 6 times 3 is equal to 18. Now, we only have two remaining operations: subtractions and addition. From left to right to solve this operation. The first one is the subtraction. So, let's subtract. 10 minus 5 is 5, plus copy this 18. The last operation would be addition. 5 plus 18 equals 23. The correct answer is 23. Let's solve another problem. 30 plus 5 times 2, divided by 10. We have three operations: addition, multiplication, and division. We need to solve first the multiplication. Let's copy 30 plus 5, and the answer for 5 times 2 is equals 10. Copy the divided by 10. Okay. The second we need to solve is the division. Copy the 30 plus 5, and the answer for 10 divided by 10 is equals 1. Lastly, addition. 30 plus 1 is equal to 31. The answer is 31. Next problem. 18 divided by 2 minus 2 plus 6 times 4. Here, we have four operations: division, subtraction, addition, and multiplication. Apply the MDAS rule. Here, we need to solve first the division. 18 divided by 2 is equal to 9. Copy minus 2 plus 6 times 4. Second is multiplication. Copy 9 minus 2 plus 6 times 4. Equals 24. Now, we only have two operations: subtractions and addition. Solve left to right. The first here is subtraction. So, 9 minus 2 is equal to 7. Copy plus 24. 7 plus 24 is equal to 31. The answer is 31. It is easy, right? That's all for now. Bye. Hi, my name is Steve. I'm your teacher buddy. Welcome to my channel. Okay, let's talk about integers. In this video, you will learn how to multiply integers. But, let's know first the rules in multiplying integers. In multiplying two integers, having the same signs, the product is always positive. In multiplying two integers, with unlike or different signs, the product is always a negative. Now, let's solve the problems. Let's multiply positive 4 times positive 3. 4 times 3 equals 12. Then, put a positive sign to the product. Because the numbers that we multiplied have the same sign, they are both positive. So, the product must be positive integer. Next, let's multiply positive 4 times negative 3. 4 times 3 equals 12. Then, put a negative sign to the product. Since the factors or the numbers that we multiplied have different signs. Next one. Negative 4 times positive 3. 4 times 3 equals 12. Here, we also have a different signs. So, the answer is negative 12. And now, let's multiply negative 4 times negative 3. Just multiply these numbers. 4 times 3 equals 12. Because the numbers that we multiplied have the same signs. The answer will be positive 12. Okay. Now let's multiply 3 integers. Let's multiply negative 2 times negative 3 times negative 2. Here we have same negative signs. But it doesn't mean that our product is a positive numbers. Because we have 3 numbers that need to multiply. Of course we solve it from left to right. Let's multiply first the first 2 numbers. Negative 2 times negative 3. 2 times 3 equals 6. And we put the positive sign because they have the same sign. Next, let's multiply. Positive 6 times negative 2 equals 12. Since the factors or the numbers that we multiplied have different signs, we put the negative sign. So the answer is negative 12. Alright. Last problem. Positive 6 times negative 2 times negative 8. Here, we have different signs. It doesn't mean that our product has a negative sign. First, let's multiply positive 6 times negative 2. 6 times 2 equals 12. Now, we put the negative signs. Because they have a different sign. So, negative 12 times negative 8 is equal to 96. Because they have the same sign. The answer will be positive 96. Good job. Now you know how to multiply integers. Wish you all the best in your mathematics adventures. Thank you for your time and have a great day. Hi. My name is Steve. I'm your teacher buddy. Welcome to my channel. In this video, I will show and explain how to convert between meter and centimeter. It means we will be converting meter to centimeter and centimeter to meter. One important thing that you need to remember is that 1 meter is equivalent to 100 centimeters. Let's answer. 3 meters is equal to how many centimeters? As I said earlier, 1 meter is equivalent to 100 centimeters. So, let's multiply 3 by 100. 3 times 100 is equal to 300. And that is the correct answer. 3 meter is equal to 300 centimeters. How about 5.5 meters equal to how many centimeters? Since we are multiplying by 100. The shortcut here is, we will move the decimal place 2 times to the right. So, from here, 1, 2. The decimal point will go here. So just add 0. So, 5.5 meters is equal to 550 centimeters. This time, centimeter to meter. We have here, 8 centimeters is equal to how many meters? Unlike earlier, we multiply the number by 100. This time, centimeter to meter. We need to divide the number by 100. So, 8 centimeters is equal to how many meters? Since we are dividing by 100. The shortcut here is, we will move the decimal place to the left. So, from here, decimal points 1 and 2. Add 0 here, so the answer here is 0.08. So, 8 centimeters is equal to 0.08 meters. Okay. How about 10.5 centimeters is equal to how many meters? 10.5 divided by 100. Let's move the decimal place 2 times going to the left. So, from here, 1, 2. Decimal point will be here and add 0. So, the answer is 10.5 centimeters is equal to 0.105 meters. Great job! Now you know how to convert between meters and centimeters. Wish you all the best in your mathematics adventures. Thank you for your time and have a great day. Thank you all for tuning in. If you enjoyed this video, don't forget to hit that like button and subscribe. And hey, why not drop a comment below? I'd love to hear your thoughts and suggestions. Until next time, bye. Hi, my name is Steve. I'm your teacher buddy. Welcome to my channel. In this video, we will talk about probability of simple events. When you say probability of simple events, this is a simple event of probability that does not need a complicated computation. Let's talk about this formula. P stands for the probability, and E is for the event. And this numerator is the number of favorable outcomes over the possible outcomes. Let's start our example number 1. What is the probability of getting ahead in tossing a coin? We all know that we have two sides in our coin, the head and a tail. So here in our problem, asking the probability of getting ahead. Head, this is our event. Then our experiment is tossing a coin. So, how are we going to calculate this using this formula? So P, or probability of the event, is head. Just put head here inside the parenthesis. Okay, so now, what is the number of favorable outcomes? Or how many head in our possible outcomes? A coin has two sides, the head and a tail. Meaning we only have one head. That's why the number of favorable outcomes is simply 1. Over the number of possible outcomes, which is 2 sides of a coin. The heads and tail. So, 2 is our denominator. Just remember, your probability is represented by a fraction, and that you need to express the fraction in lowest terms. In this case, 1/2 is already in lowest terms. But you also can express this 1/2 as a decimal like 0.5, and also you can answer this as 50%. I hope that's our first example. You learned on how to use this formula in calculating the simple events. Now let's move on with the next example. Peter spins a spinner. What is the probability of the spinner will land on 3? So, as you can see, we have here a spinner. We have 4 parts of our spinner. Our experiment here is spins a spinner. And we are asked, what is the probability of the spinner will land on 3? Our event here is 3. So, we have the probability of 3 equal to the number of all favorable outcomes. Now, look at the spinner. How many 3 you see? 1, right? Therefore, our number of favorable outcomes in this problem is simply 1 over number of all possible outcomes. We have 1, 2, 3, and 4. Meaning, the denominator is 4. Let's simplify our answer. 1/4 is already in lowest terms, that's why this is our final answer, or 0.25 in decimal, or 25%. I hope this video helped you better understand on how to solve the probability of simple events. Wish you all the best in your mathematics adventures. Thank you for your time and have a great day. Shout out to Adri and Jasmine for requesting this video. Thank you all for tuning in. If you enjoyed this video, don't forget to hit that like button and subscribe. And hey, why not drop a comment below? I'd love to hear your thoughts and suggestions. Until next time, bye. Hi, my name is Steve. I'm your teacher buddy. Welcome to my channel. In this video, you will learn about the properties of real numbers. What are the properties of real numbers? The properties of real numbers are: first, the associative properties, commutative properties, inverse properties, identity properties, and distributive properties. Remember, the properties of real numbers hold through addition and multiplication. Let's talk about associative properties. From the word itself. From the root word of associative. We are talking about associate. When we are associating, we are grouping. Remember, the word equal in associate is group. That means in associative properties we are grouping. So, it doesn't matter how you group or associate addition or multiplication, the answer will be the same. In associative property of addition, the rule is A plus B plus C is equal to A plus B plus C. As you can see, the first group is A plus B and the next group is B plus C. But don't get me wrong, we are adding A, B and C. Only the difference in associative property, that it doesn't matter how you group, the answer will be the same. And the rule for the associative property of multiplication. Even how you group as multiplication, the answer will be also the same. Let us prove the property. Let's have an example. First, let A is equal to 1. And B is equal to 2. And C is equal to 3. Same with the other group. So, 1 plus 2 is equal to 3 plus 3. Equal to 1 plus, what is 2 plus 3? It's 5. So, 3 plus 3 is equal to 6. And then, 1 plus 5 is also equal to 6. That means it's applicable. The associative property of multiplication. Even how we group, it will get the same answer. How about this one? Our A is 2, B is 3, and C is 4. Same with other group. Let's multiply. 2 times 3 is 6. Times 4 equals to 2 and multiply 3 times 4 is equal to 12. Then 6 times 4 is equal to 24. And 2 times 12 is equal to 24. That's it. That is the rule of associating property in group multiplication. The answer will be the same. Next property is commutative properties. We have commutative property for addition and commutative property for multiplication. So the root word for commutative is commute, which means travel or move. It doesn't matter how you swap addition or multiplication around. The answer will be the same. Just remember the word commute. Let's say for example from one place to another place. If you traveled back and forth, you still traveled the same kilometers or the same distance. It doesn't matter. For example, in commutative property of addition, A plus B is equal to B plus A. We will still get the same answer. Let's have an example. Let's say, our 1 is A, and 2 is B. 2 is B, and 1 is A. A plus B is the same with B plus A. So, 1 plus 2 is 3, and 2 plus 1 is also 3. That means, the commutative property of addition. Doesn't matter how you swap the number, as long as we have the same numbers, we will get the same answer. How about a commutative property of multiplication? We have 2 times 3 equals 3 times 2. So let's say for example, our 2 is A, and 3 is B. 2 times 3 is 6. 3 times 2 is also 6. That means, in commutative property of multiplication, it doesn't matter how you swap the number, as long as we multiply, we will get the same answer. Let's move on to inverse properties. You have to think inversely when you think inverse. It is the opposite. What is the opposite or inverse of addition? It's subtraction. We add the negative to get the opposite. And what is the opposite of multiplication? It's division. Multiplying it by its reciprocal. Let's say, for example, in inverse property of addition, a, if we add the negative, it's automatic 0. So, a plus negative a is equal to 0. In multiplication, a, if we add the reciprocal of a, meaning reciprocal, the opposite of a, is automatic represent to a over 1. If we multiply this to the opposite, it will become 1 over a, and the answer is 1. Let's have an example. In inverse property of addition, 3, the inverse of 3 is negative 3. When we add 3 and negative 3, the answer is 0. In inverse property of multiplication, we have 2. Automatically, we have the denominator of 1. Let's multiply the reciprocal, which is 1/2. 2 times 1 is 2. And 1 times 2 is 2. 2 over 2, when we simplify it, is equal to 1. So basically, this is the inverse property of multiplication. Again, if we talk about the inverse property of addition, the answer will be 0. While the multiplication, the answer will be 1. And that's what we call inverse. How about identity property? What can you add to a number and get the same number back? What is the answer? 0, right? For example, 1 plus 0, the answer is 1. 5 plus 0, the answer is 5. 7 plus 0, also the answer is 7. What can you multiply a number by to get the number back? It's 1. For example, 5 times 1 is 5. 8 times 1 is 8. 10 times 1 is 10. For the rule of identity property of addition, a plus 0, the answer will be a. In multiplication, a times 1, the answer is also a. The identity of a is not changed. For example, our a is 3. If we add 0, the answer will be 3. If we multiply, for example, our a is 2. 2 times 1, the answer is 2. Next is distributive property. For the word itself, distributing. If something is sitting just outside a set of parentheses, you can distribute it through the parenthesis with multiplication and remove the parenthesis. Remember, in distributive property, we need to see the multiplication and the parenthesis so that you can distribute it. For the rule, let's say, for example, a times b plus c is equal to. We need to distribute by multiplication. So, a distributes to b. A also distributes to c. The answer will be a times b plus a times c. Good job! Now you know the properties of real numbers. Wish you all the best in your mathematics adventures. Thank you for your time and have a great day. Thank you all for tuning in. If you enjoyed this video, don't forget to hit that like button and subscribe. And hey, why not drop a comment below? I'd love to hear your thoughts and suggestions. Until next time, bye. Hi, my name is Steve. I'm your teacher buddy. Welcome to my channel. Okay, let's talk about fractions. And of course, this is everyone's favorite topic. But, in actuality, Most math students, when they see fractions that have one or two expressions, they're very angry. Or some people get upset. Then others are totally just lost. But if you stick with me for a couple minutes, I'm going to give you some outstanding little ways to remember how to deal with fractions. You're going to be very happy. And what we're going to focus on is how to do the following operations with fractions. We're going to learn how to add, subtract, divide, and multiply. Of course, mostly out there probably already learned this. But most students get confused, and they struggle. Because there are things involved like finding the lowest common denominator. But again, we're going to go ahead and give you a nice quick power lesson. You're going to find fractions much easier. Okay. So let's get into fractions. How we multiply and divide fractions. The other half is addition and subtraction. And this is where most people don't like. Because this requires a little bit more work when you have to do like the LCD, the lowest common denominator. So, if you remember that and you hate finding the LCD, well, I'm going to give you a nice little shortcut. I'm going to call it a hack. First rule: multiplying and dividing fractions. Take a look at a couple examples. So, here we have 2/3 times 1/5. Now, just a quick review. The top number in a fraction is called the numerator. The bottom number is called the denominator. Okay, but here's what you need to know when we're multiplying fractions. The way we multiply fractions is we simply multiply the respective numerators. So, in this case it's going to be 2 times 1. And then, we're going to multiply the respective denominators. That's 3 times 5. So, 2 times 1 is 2. 3 times 5 is 15. You're done. Now, let's talk about how to divide fractions. What we're going to do is we're going to convert them into multiplication problems. So, we don't really divide fractions. I mean, technically. But we're going to change the problem into a multiplication problem. So, let's take a look at this problem. 2/3 divided by 1/5. So, we're going to change this problem from division to multiplication. Okay, but how do we do that? Well, you have to pay attention to the fraction to the right of division symbol. The fraction to the right of it is 1/5. Now, here's how you change this problem to multiplication. You simply take the fraction to the right of the division symbol, and you flip it upside down to 5/1. That's called the reciprocal. And now this becomes a multiplication problem. Now, we're simply going to multiply across, so that's going to be 2 times 5. Of course, is 10, and 3 times 1 is 3. Voila! Let's go ahead, dealing with mixed number fractions. Something like 2 and 1/5. And we're going to multiply it by 1 and 1/3. Well, what you're going to do is rewrite these fractions as improper fractions. So, for example, 2 and 1/5. I can write that as a single fraction by going 5 times 2. That's 10, then I add 1, so that's going to be 10 plus 1 or 11/5. And then, 1 and 1/3 as an improper fraction. 3 times 1 is 3, plus 1 is 4 or 4/3. So, now I'm just going to simply multiply across. So, 11 times 4 is 44. And 5 times 3 is 15. And we're done. Okay, you already know how to multiply and divide fractions. Let's get into our second rule. Focusing on how to add and subtract fractions. And again, this is where you have to be thinking about the lowest common denominator. But, I am going to give you a lovely hack here in just 1 second. It's like a shortcut. So, let's take a look at this problem. Here I have 2 7 plus 1 7. So, I'll look at the denominators, they are the same. That's 7. So, if the denominators are the same, We're going to keep that denominator in our answer. And then we're going to add the numerators, so this is 2 and this is 1. So that's going to be 2 plus 1 is 3. And that would be 3 over 7. And that is it, okay. Pretty easy to add and subtract fractions. Especially if the denominators are the same. So, if the denominator is the same, we simply add or subtract the respective numerators and we'll get our final answer. Again, that's not that difficult, but here is where the fun starts. What happens when the denominators are not the same? You do need to think about what the LCD is, and you have to learn how to find the LCD. This is very important. However, what I'm doing in this little lesson is giving you a shortcut. So, if I have this fraction, 2/5 plus 1/3. I want to add these together, but they don't have the same denominator. And this is the way most of you answer this question using the LCD method. Right? But hey, what if you don't want to deal with the LCD? Well, you're in luck because you're watching this video. I want you to remember this little symbol right here. It's called a bow tie. This is the general pattern. Always start from the bottom right and you go this way first. So, we're going to do 3 times 2, we're going to put our answer there. And then you're going to go from the bottom left. And you're going to go this way. So, you can see it has like a little crisscross pattern. We're going to put that answer there. So, let's do that. 3 times 2 is 6. Now, this is an addition problem that's going to be plus. 5 times 1 is 5. That's our numerator. Over, our denominator is going to be 5 times 3. So, here's our bow tie. 5 times 3 is 15. Now we simplify that 6 plus 5 is 11 over 15. And that's the correct answer. This is the bow tie method. You're going to want to know this not only for arithmetic, but for variable fractions as well. It is easy, right? That's all for now. Bye.
Learn with Lily.
Hello there! In this video, we are going to learn about contractions. But first, what are contractions? Contractions are a shortened form of two words combined by an apostrophe that takes place of the missing letter or letters. Let's have a look at some examples. If we combine the two words did and not together, the contraction would be didn't. As we said before, an apostrophe is used in place of the missing letter or letters. In this case, the letter O was replaced by an apostrophe when we contracted the two words did and not. Let's use these words and the contraction in a sentence. I did not eat my breakfast. I didn't eat my breakfast. Let's combine these next few words together to make other contractions. I and will makes I'll. Can you see which letters were replaced by the apostrophe? That's right. It was W and I. I will clean my room. I'll clean my room. Next is I and have makes I've. Now for this contraction, the apostrophe has replaced two letters, H and A. I think I have got the highest score. I think I've got the highest score. It's your turn. Can you write these contractions for these examples? Does and not. Is and not. They and will. What and is. Can and not. We and are. Time to check. Let's see how many you got right. Does and not makes doesn't. Is and not isn't. They and will they'll. What and is what's. Can and not can't. And we and are we're.
Wow.
Good job! I hope this video helps you better understand about contractions. Thank you for watching and don't forget to subscribe. Bye now! Shout out to Galaxy Plays for recommending this video. Leave a comment down below on which lesson you want us to teach you next.
Learn with Lily.
Hello there! In this video, we are going to learn about the prepositions of time. What is a preposition? The preposition is one of the 8 parts of speech in which it is a word that links a noun into other words in a sentence. And in this topic, let's focus on prepositions of time. In this inverted pyramid, having 3 prepositions of time, the in, on, and at. As you can see, this is an inverted pyramid because these 3 prepositions of time come from general to most specific. In, we use it as general, like time expressions. And on is a little general. And the at is the most specific among them. Let's now take a look at our first preposition of time, which is in. The preposition in is the most general among the 3. We use it in months, seasons, years, decades, centuries, long periods, and parts of the day. The first one we have is the months, such as January. In January, in February, in March, in April, in May, in June, in July, in August, in September, in October, in November, and in December. Let's try to use it in a sentence. My birthday is in July. My birthday is in July. The next one is, we are also going to use the preposition of time in for seasons. What are the different seasons? We have winter, spring, summer, and fall. So the example we will have here is in summer. I will be finishing my thesis in summer. Next, we have years. In 2012. In 2012, the year I was born. In 2000s, in 2001, and in 2024. Example sentence is, the entire world has stopped in 2020 due to the pandemic. Next, we have decades. A decade is equivalent to 10 years. So we can say in the 80s, in the 1980s. Let's have an example. Most of the millennials were born in 1990s, or most of the millennials were born in the 90s. We can also use in for centuries. If a decade is equivalent to 10 years, a century is equivalent to 100 years. We may say in the 21st century, in the 19th century, in the 20th century. Let's try using it in a sentence. Most of the advanced gadgets are discovered in the 21st century. And we also have for a long period, such as in the past, in the present, in the Ice Age. In the past, many people relied on handwritten letters to communicate over long distances. And lastly, parts of the day. Example, in the morning. That's general because we don't know what time in the morning. In the afternoon, in the evening. But we cannot say in night. That's not grammatical. Although night is part of the day, but the preposition that we use for night is at. At night. Once again, we use the preposition of time in for months, seasons, years, decades, centuries, long periods, and for parts of the day. Now, let's take a look at the next preposition of time, on. As I told you, in this inverted pyramid, the preposition of time in is the most general use. And the next is the preposition of time, on. But where do we use the preposition of time, on? We use on for the days, dates, and parts of the specific day. Let's have an example for the days. On Monday. That's a particular day. On my birthday. For example, the start of classes is on Monday. The start of classes is on Monday. Sometimes we hear on Mondays, on Sundays, on Tuesdays. Just remember, when we say on Monday, it refers to one specific Monday. But when we say on Mondays, it always happens on Mondays. Just like when I say, I'm going to the church on Sunday. Meaning that I am going to the church on Sunday. But if I say, I go to the church on Sundays, it means that I go to the church every Sunday. You get it? Next, we have dates. For example, on July 7th. On July 7th. As you remember, the preposition in, we use it in months. Like in December, right? But we cannot say on December. We will use on if we have a specific date, okay? Most of us, we are used to say, for example, December 25, 2020, January 1, February 14th, March 30, etc. That is what we used to do. But the correct way is, whenever we are going to state a particular date, is the ordinal number. What is the ordinal? It is the first, second, third, fourth, fifth, and so on. just like this. My birthday is on July 7th. My birthday is on July 7th. And for the last usage of the preposition of time on is parts of specific day. The example we have here is on Saturday morning. On Saturday morning. I am going to the gym on Saturday morning. Another example. On Sunday evening. I am going to deliver your order on Sunday evening. Awesome! Once again, we use the preposition of time on for the days, the dates, and for the parts of specific day. And for the last one, the preposition of time at. This is the most specific among them all. We use at. First, in the times of day. We use it at a specific time of day. We can say at 5 o'clock, at 6 o'clock. But it is wrong if we say at 5 p.m. o'clock. You can say at 5 o'clock in the evening or 5 o'clock in the morning. At noon, this is a specific time of the day, meaning that we are sure that noon arrived. It is 12 o'clock. Let's try to use it in a sentence. The due date of my project is at 5 o'clock. The due date of my project is at 5 o'clock. Next is meal times, such as at lunchtime, at lunchtime, at dinner time, at dinner time. Let's try to use it in a sentence. We are going to meet at lunchtime. We are going to meet at lunchtime. And lastly, expressions. We are using the preposition of time at in an expression, such as at present. That is specific. At night. And at the moment. I am so happy at the moment. Once again, we are using the preposition of time at for the times of the day, for meal times, and for expressions. Let's have a short quiz. What preposition of time we're going to use? 10 o'clock, January, Monday morning, the moment, the past. Time's up. Let's answer. 10 o'clock. At 10 o'clock. January. In January. Monday morning. On Monday morning. The moment. At the moment. The past. In the past. Good job! I hope this video helps you better understand the preposition of time using in, on, and at. Thank you for watching and don't forget to subscribe. Bye now! Did you learn something from this video? If so, please give it a thumbs up, share it with your friends, and subscribe to our channel. Also, don't forget to hit the notification bell so you won't miss any of our future lessons.
Learn with Lily.
Hello there! In this video, we are going to learn about metaphors. What are metaphors? Metaphors are a type of figurative language that are used to directly compare two things. Unlike similes, which use the words like or as to compare two things, metaphor says that one thing is something else but not in a literal way. Let's have a look at some examples. The classroom was a zoo. The classroom isn't really a zoo. It's just really crazy. Which is why this is a form of figurative language. If you ever come across this metaphor, it simply means that the students in the classroom is just very noisy. Remember, similes use the words like or as to compare two things, whereas metaphors say that one thing is actually something else. But remember, not literally. This metaphor is saying the classroom was a zoo. So, if we wanted to change this metaphor into a simile, it would sound something like, the classroom is like a zoo. My sister is an absolute angel. Can any human ever be a real angel? No. This metaphor is directly comparing her sister to an angel because it's saying that she is a very well-behaved girl. Can you think of how this is different to a simile? Remember, we would have to use the word like or as, so if we were to change it into a simile, it would sound something like, my sister is like an absolute angel. My mouth is on fire. Of course, the person's mouth isn't actually on fire. What the writer is implying here with this metaphor is that their mouth is feeling intense heat because they have possibly eaten something very spicy. How would this sound if we tried to change it into a simile? It would sound something like this. My mouth feels like it is on fire. She is a shining star when she dances on stage. In this metaphor, the writer is directly comparing the abilities of a dancer to a bright and shining star. That means she is an outstanding and talented dancer. My mother is a night owl. In this example, the mother is not a real owl, but rather she is someone who tends to stay up late at night, just like an owl. That's all for now. Good job! I hope this video helped you understand better about metaphors. You can leave me a comment, suggestions, or you can even make a request if you have a topic that you want me to do. Thank you for watching and don't forget to subscribe. Bye now.
Learn with Lily.
The apples are. Is this a complete sentence? No. How about this one? Are red. Is this a complete sentence? No. This is not a complete sentence. Hello there! In this video, we are going to learn about sentence fragments and learn what makes a sentence complete. So, what is a sentence fragment? A sentence fragment means that parts of a sentence are missing. When that happens, you have an incomplete sentence. But what does a sentence need to make it complete and whole? Well, you need a subject and a predicate to make a complete sentence. Let's take a look at the sentence. Apples are red. Apples is the subject. It tells us what we're talking about. Red is the predicate. It tells us what the subject is. This sentence has both the subject and the predicate, so it's a complete sentence.
Woo!
Now let's look at more sentence fragments and turn them into complete sentences. Drinks milk before sleep. Something is missing from the sentence. What part of the sentence is missing? How can we make this sentence fragment complete? That's right. It's missing the subject who drinks milk before sleep. It's Audrey. Audrey drinks milk before she sleeps. Audrey is the subject. Let's look at another one. The cat. That's not a complete sentence. We're missing a very important part. We have the subject, the cat, but we have no predicate to tell us what the cat does. Right? So let's fix it to make the sentence complete. The cat likes to play. There you go. Now we have a subject and a predicate to complete the sentence. Do you understand what makes a complete sentence now? All you need is a subject and a predicate. We like to play. My teacher is nice. The house is big. If the sentence misses one part of the sentence, whether it's the subject or the predicate, the sentence is fragmented and it's not complete. But wait! There is one exception to this rule. In imperative sentences or commands, you don't need the subject. When you are giving someone a command or telling someone to do something, the subject is assumed. Here are a few examples of imperative sentences or commands which have no subjects but are still considered complete sentences. Stop talking. Wait for me. Be quiet. Nobody move. None of these sentences have subjects, only the predicate. But they are still considered complete because they are all commands. Now, let's have a little quiz. Can you guess if the sentences are complete or incomplete? Makes breakfast. My father and I went fishing. Open the door. Time to check. Makes breakfast is an incomplete sentence. This sentence has no subject. We don't know who is making the breakfast. My father and I went fishing. That's a complete sentence. This sentence has both the subject and the predicate. And the last one, open the door. It's a complete sentence. This is a confusing one because it looks like the sentence is fragmented. It's missing the subject. However, it's a command. It tells someone to do something, but it is considered as a complete sentence. I hope this video helped you better understand about sentence fragments and distinguish between complete and incomplete sentence.
Wow.
Thank you for watching, and don't forget to subscribe. Bye now.
Learn with Lily.
Hello there. In this video, we are going to learn about regular and irregular form of the verb. There are two types of verb in the past form. One is regular verbs and the other is irregular verbs. Some verbs form their past tense by adding d or by adding ed. These verbs are called regular verbs. Danced, baked, loved, watched, cooked, and played. These are regular verbs. More examples: present tense and past tense. Present tense is invite, past tense is invited. Bake, baked, name, named, love, loved, die, died, care, cared, close, closed. In sentences, my mother baked a cake last night. We watched our favorite show last week. Now, some verbs form their past tense by changing the spelling. These verbs are called irregular verbs. For example of present tense and past tense: sit, sat, eat, ate, sleep, slept, give, gave. Here's more examples: drink, drank, come, came, see, saw, blow, blew, grow, grew, know, knew, sing, sang, go, went, get, got, and drive, drove. Give the past form of the verb call, called, play, played, clean, cleaned, sing, sang. I hope this video helped you better understand about regular and irregular verbs. Thank you for watching, and don't forget to subscribe. Bye now.
Learn with Lily.
Hello there. In this video, we are going to learn about the question mark. A question mark is used at the end of a question. A question has several names. It can be called a question, or an interrogative sentence, or maybe an asking sentence. A question mark can look like this. Let's go ahead and make a few asking sentences or interrogative sentences. This is Madel and this is Peter. Madel will ask questions with a question mark at the end, and Peter will answer with a period at the end. Ready? What's your name? My name is Peter. How old are you? I'm 12. Would you like some cookies? Sure, thank you. At the end of every question asked by Madel, there was a question mark. Simple as ABC, right? Now, are you ready for a quick quiz? I'm going to give you several sentences, and you're going to determine if there should be a period or a question mark at the end of each sentence. Are you ready? It's chilly outside. Can you close the window? Thank you for closing the door. Which punctuation do you need at the end of these sentences? A period or a question mark? Time to check. It's chilly outside. It's a period. Good job. Yeah! Can you close the window? It's a question mark. Bravo. Yeah! And thank you for closing the door. It's period. Awesome. I hope this video helps you better understand about question mark punctuation. Thank you for watching and don't forget to subscribe. Bye now.
Learn with Lily.
Hi there. In this video, we're going to learn all about proper nouns. A proper noun gives a special name to a common noun. A proper noun and a common noun. They're both nouns, so how are they different? First of all, do you remember what a common noun is? Common nouns are general. They usually name classes of things, people, and places rather than specific things, people, and places. They are only capitalized at the start of a sentence, and they can be modified by articles, determiners, and adjectives. A boy is a common noun because a boy is a person. But wait, let's give him a special name. What's his name? It's Stephen. Stephen is a proper noun because it's the special name of the boy. A boy is a common noun and Stephen is a proper noun. We're not done yet though. Look at his name again, Stephen. Something needs to be changed, but what? It is when you give someone or something a special name, you must capitalize the first letter. So let's fix that. A capital S for Stephen. Let's think of a place as a common noun. How about a country? Great. Now let's come up with a proper noun. Remember, a proper noun gives a special name to the common noun. How about Japan? That's the name of a country. A country is a common noun because it's a place generally, and Japan is a proper noun because it's a special name of that country. Now, Japan is a proper noun, so don't forget to capitalize the first letter of each word. Capital J. Japan. Remember, every first letter of each word in the proper noun must be capitalized. How about animals? Let's come up with an animal common noun. Do you have a pet? What kind of animal is it? Let's say a dog. Now, we need a proper noun for the dog. What's the special name given to this dog? It's Shiro. But wait, look at Shiro. What's wrong? Don't forget to capitalize the first letter S because Shiro is a proper noun. Shiro is a proper noun because it's a special name given to the dog. Which common noun are we missing? We've covered a person, place, and animal. Oh yes, a thing. Let's come up with things as a common noun. How about a movie? Now we need a proper noun for a movie. Which movie should we choose? Harry Potter. I do love all things like magic. Harry Potter. So a movie is a common noun because it's a thing. Harry Potter is a proper noun because it's the name of a movie. Now, don't forget to capitalize the first letter of each word in that proper noun. Marga. Can you tell me if this word is a common noun or a proper noun? Marga. Marga is a special name of a girl, so it's a proper noun. Park. How about a park? A park is a place, so it's a common noun. Good job! But look, if we just give it a special name, Luneta Park, it's now a proper noun. And because it's a proper noun, we should capitalize the first letter of each word. I hope you now understand the difference between a common noun and a proper noun. Just remember that a common noun is a person, place, animal, or thing, and the proper noun gives a special name to a common noun. One more thing you need to remember is to capitalize the first letter of every word in a proper noun. I hope this video helped you better understand about proper nouns, and thank you for watching, and don't forget to subscribe. Bye now!
Learn with Lily.
For this video, we will talk about point of view. Point of view is the perspective of the narrator. There are three types of point of view: first person, second person, and third person. First person talks about the person talking in the conversation. For example, I and me. In a sentence, I have a pet parrot. Second person talks about who the person exchanges the conversation with. For example, you. In a sentence, you have shiny shoes. Third person talks about someone who is not directly in the conversation. For example, he and she. In a sentence, he has a big pillow. And that's all for today. See you next time.
Learn with Lily.
The sun smiled at me. Is it possible that the sun can be able to smile? Hello there. In this video, we are going to learn about personification. What is personification? Personification is when you give human qualities to something that is non-human. It is a type of figurative language, and it is used to make stories come alive and more interesting for the readers. Using personification in your writing can help readers to have emotional responses to your text. It can also help your audience to create strong visual imaginary in their minds about what you are trying to express or convey. The sun smiled at me. This is an example of personification because smiling is something humans can do. But the sun is non-human, and it is an object. It is unable to smile. The personification here suggests that the sun was shining brightly and a lot of warmth can be felt. More examples. The moon slept through the night. We all love to sleep, I'm sure, but we also all know that it is impossible for the moon to sleep as it is a non-human object. The writer may have wanted to convey here that it was a quiet and peaceful night. Another example. The teapot sang its little song, meaning that the sound made by boiling water in the teapot. The mountains bow to the heavens. It means that the mountains are tall, majestic, and humble before nature's vastness. The fire danced in the fireplace. It means that the flames moved rapidly and unpredictably. It's your turn. The flowers dance in the breeze. What do you think the personification here is trying to suggest? The flowers danced in the breeze. That's right. The flowers swayed gracefully due to the wind. Good job! I hope this video helped you better understand about personification. Thank you for watching, and don't forget to subscribe. Bye now!
Learn with Lily.
Hello there! In this video, we are going to learn all about the personal pronouns. Before we start, let's take a look at these sentences. Annie is a girl. Annie likes to dance. Annie won many dancing competitions. Can you think of a way to make these sentences flow more naturally? We'll come back to this in a few minutes, but first, what's a personal pronoun? A personal pronoun replaces a noun or nouns in a sentence. There are two kinds of personal pronouns, subject and object. First, we're going to focus on subject pronouns. I, you, he, she, it, we, and they. A subject pronoun usually comes at the beginning of a sentence and does the action in the sentence. Dixie bakes a carrot cake. In this sentence, Dixie is the noun, or more specifically, a proper noun. What should we replace Dixie with? Dixie is a girl, so we're going to replace it with she. She bakes a carrot cake. What about this sentence? Rex likes to sing. We're going to replace Rex with a pronoun. Rex is a boy, so we'll replace it with he. He likes to sing. Let's look at the next sentence. Amari and I walk to school together. Let's replace Amari and I with a pronoun. Amari and I should be replaced with we. We walk to school together. Are you ready for the next one? The box is in front of the door. Which pronoun will you replace the box with? The box is a non-human object, so we'll replace the word with the pronoun it. It is in front of the door. What if there are multiple things or people like in this sentence? Amari and Candice built a snowman. What should we replace Amari and Candice with? There's more than one person as a subject, so it's they. Good job! They built a snowman. Then what about the pronoun I? We don't talk about ourselves by our first name, right? That would just be silly. My name is Lily, but I don't say, Lily is hungry, Lily wants dinner, Lily wants a pizza. Now, that's just silly. So which personal pronoun do we use instead? I. That's right. I am hungry. I want dinner. I want a pizza. What about the pronoun you? When someone talks to you, it would be strange for that person to say your name over and over again. So that person will replace your name with the pronoun you. You are watching this video right now. Alright. Let's go back to the paragraph. You read at the beginning of this video, Annie is a girl. Annie likes to dance. Annie won many dancing competitions. How can we make these sentences flow more naturally using pronouns? We're going to replace all of the Annie's pronouns except for the first one because we need to know who we're talking about. So, here we go. Annie is a girl. She likes to dance. She won many dancing competitions. Wow, that sounded more natural. Now, let's focus on another type of personal pronouns, the object pronouns. Me, you, her, him, it, us, and them. An object pronoun is the receiver of the action. Amber gave Arya a balloon. Who is the receiver of the action? Arya. So, let's go ahead and replace Arya with one of the object pronouns. Arya is a girl, so it's her. Amber gave her a balloon. Shall we look at some more examples? I helped Yuri plant a tree. Yuri is a boy, so we're going to replace it with the pronoun him. That's right. I helped him plant a tree. What about this one? Can you tell your friends to come on Saturday? Let's replace your friends with a pronoun. Now, friends means that there's more than one. So which pronoun should we choose? That's right, them. Can you tell them to come on Saturday? You did a fantastic job learning all about personal pronouns. I hope this video helped you understand how to speak and write without using the same nouns over and over again. Thanks for watching and don't forget to subscribe. Bye now.
Learn with Lily.
Hello there. In this video, we are going to learn about the symbol period. Have you ever seen a little circle or a dot at the end of a sentence? It's called a period. So, when do we use it? We use it in a declarative sentence. It's also called a statement, a telling sentence. We use a period to show that a declarative sentence or a statement has ended. We have expressed a complete thought. The sentence has finished. Let's make a few statements. Shiro, my pet dog, is a Pomeranian. My dog is very friendly. She always wants to play with me. Do you see it? Do you see that all of these are telling sentences, and there is a period at the end of each sentence? Here's another one. Marga is happy. She is 10 years old. She loves to eat. There is a period at the end of each sentence. Good job! You can also use a period at the end of a command. A command is a sentence that tells someone what to do, and it can even just be one word. Stop. Go away, please. Close the door. Go straight. Now, can you make a command sentence? What would you tell a cat to do? I'd say something like jump, run, trample. Now you know how to use this little dot or a period. Good job! I hope this video helped you better understand about periods. Thank you for watching and don't forget to subscribe. Bye now!
Learn with Lily.
Hello there! In this video, we are going to learn about irregular plural nouns. Irregular plural noun is very simple. All you need is an S or an ES at the end when there is more than one object. One dog, two dogs. One apple, two apples. However, an irregular plural noun is a little different. It doesn't have the same rules as regular plural nouns. You don't simply just add S or ES. We're going to look at 4 kinds of irregular plural nouns today. First, nouns that end in F and FE. Second, nouns that change vowels in the middle. Third, nouns that change in spelling greatly. And last, nouns that do not change at all. Are you ready? So first, Let's look at the nouns that end in F and FE. Elf. All you have to do is change the F to a V and add ES. 1 elf, 2 elves. Here are more examples. 1 leaf, 10 leaves. 1 calf, 2 calves. 1 scarf, 5 scarves. What about the ones that end in FE? Well, it's the same thing. You just have to change the FE to the V and add ES. 1 knife, 2 knives. 1 wife, 2 wives. 1 life, 8 lives. Next, let's look at the nouns that change their vowels in the middle. A, E, I, O, and U. Man. What is the vowel here? A. That's right. 1 man. Then, what about 2? Who will change A? It's E. 2 men. Let's try another example. 1 foot. Change the vowel sound to make it plural. What is the vowel sound here? Ooh, that's right. Change to EE. 2 feet. Good job. Woo! Next, let's look at the nouns that change spelling greatly when made plural. These irregular plural nouns are the trickiest because you just have to memorize them. 1 mouse. 3 mouses. Nope. 3 mice. That's right. 1 child. 2 childs. Nuh-uh. It's children. 1 ox. 3 oxen. Good job.
Wow.
Now, we have one more type of irregular plural noun. The ones that just stay the same and do not change at all. There is 1 sheep. What about 10? 10 sheeps? Nope. They are 10 sheep. It doesn't matter how many sheep there are, it'll always be sheep. Let's explore more of this kind. 1 fish, 20 fish. 1 moose, 5 moose. 1 deer, 10 deer. Good job! Let's have a quiz. What are the plural nouns of the following words? Mouse, goose, leaf, teeth. Time to check. Mouse is mice. Goose is geese. Leaf are leaves. Teeth are tooth. Great job! I hope this video helped you better understand about irregular plural nouns. Thank you for watching and don't forget to subscribe. Bye now!
Learn with Lily.
For this video, we will talk about has, have, and had. These words are used for possession and or ownership. Singular means only one subject. Plural talks about 2 or more subjects. Singular, she, he, a book, a bottle. While plural, they, theirs, books, and bottles. For singular subjects, we use has. But for plural subjects, we use have. An example for singular, she has a cat. For plural, they have a cat. But let's talk about had. We use had if it is in the past. For example, he once had a car. We use had because he used to have a car in the past, but he doesn't own one now. That's in 1 minute. Thank you.
Learn with Lily.
Hello there! In this video, you're going to learn about the exclamation mark. An exclamation mark is a punctuation that goes at the end of exclamatory sentence. So what's an exclamatory sentence? An exclamatory sentence is a sentence that expresses strong emotion, feeling, or to show emphasis, like shock, anger, joy, excitement. All of these strong feelings. Let's look at some examples. Our team just won the best project in our school. How would you express this joy and excitement? Would you say, "Yes, we won," or "Yes, we won"? Exactly. We want to use exclamation mark to show that we are super happy and excited. Here's another one. Josh wants to show that he was really amazed by the gift that he received on his birthday. That was the best gift I received ever. That almost sounds sarcastic. Let's try that again. That was the best gift I received ever. Yay! The exclamation mark is used to show how excited Josh is. Let's use an exclamation mark to show anger and frustration. Adri is blamed for something he didn't do and he's angry about it. Adri, you took everyone's apples, didn't you? No, I didn't. I really didn't. By adding the exclamation mark, you're showing more emotion than using just a period. You can also use an exclamation mark at the end of a strong command. Maybe you want to tell someone to do something, but with more force. Be careful. Go away. Don't touch that. If someone keeps bothering you even after you told them to stop, say it with more force. Stop that! An exclamation mark. Lastly, you can use an exclamation mark at the end of an interjection. An interjection is a word or phrase that shows a short and sudden burst of emotion. Here are a few examples. Ouch! Wow! Boo! Yuck! Fantastic! No way! Hey! Good job! You did amazing! Staying tuned and learning all about when you can use an exclamation mark. Just remember, use it when you want to show strong emotions or to show emphasis. Just a little warning that you shouldn't use it too much or it'll just look like you're yelling. I hope this video helped you better understand about the punctuation and exclamation mark. Thank you for watching and don't forget to subscribe. Bye now.